Now let's move into general triangle. So a general triangle is any triangle, whether it's right triangle or not right triangle, it's any triangle basically. So it has three sides, A, B, and C. It has three angles, capital A, capital B, and capital C. And two laws applies here, the law of sines and the law of cosines. So the law of sine is A. A here is the side A, over sine A, capital A, the angle here, equals B over sine B equals C over sine C. And these are corresponding, so A corresponds to capital A, B corresponds to capital B, C corresponds to capital C. And then we have the law of cosine, which is a generalization of the Pythagorean theorem. So basically, if you simplify this one into this form here for right triangle, so basically if you put the angle here as 90, this term here will cancel, and you will be left with the Pythagorean, the normal Pythagorean theorem. But if you use this one, it's a general form that could be used to a general triangle or any triangle. So let's take an example here. So what is the approximate height of the flagpole? So basically we have this flagpole here and we want to find its height. So basically this height is nothing but the y component of this base over here, of this side over here. So basically the height would equal b sine, and what is the angle here is 37 degrees, and we have this notation here 11. So I will show you what does it mean when we start using the calculator. So what we need to do is to find this b in order to find this h. How can we find this b? So we can use the law of sines, here. So the b here is corresponding to this angle b here, and this c here corresponds to this BA side length here, 17. So what we can do, we can say that b over sine 25 degrees 43 dash equals 17 over sine. And now we need to find this angle here. So let's call it phi. Now, how can we find this angle phi here? We cannot find it simply from here because, or we could find it, there are multiple ways. We could find it from this one here, or we can just use what the book used here. So basically the book found this angle here, theta. So basically what it did, there are multiple ways to solve this question. So we have this angle here, and this is 90 degrees here. So what we will have is 3711 plus 90 plus this theta. This will equal 180. And now let's plug this into the calculator and get the theta. I will show you how to write the notation that we wrote earlier. So this is 37, and in order to write this notation, we'll put this button, and then we'll put 11, and then press the button again, and this will give us the notation. So basically this 11 means 11 over 60. Because this notation is not just used with angles, it's used with minutes and hours as well. So this will be 37.183, which is equivalent to 37 and 11 over 60. So let's continue here, plus 90 plus x equal 180. Let's solve and we will find it to equal. So from here we have theta equal 52.82 degrees, and then we can use the bigger triangle to find the other angle, which is the phi. So basically what we will have here is 25 degrees 43 plus 90 plus the two angles, the theta and the phi. So the theta we have found it to be 52.82 plus the phi equals 180, and then we can simply solve this and we will get the phi to equal 11.46 degrees. And now what we need to do is to use the law of cosine that we found earlier in order to find the b. So we will just plug in the value of the angle that we have found here, the phi, into this location here, 11.46, and then we will use the calculator to find the b, which we will find it to be 37.11. And then let's find the h here. So the h will be b because it's the h is nothing but the y component of the b, so it will be b sine 37 degrees 11. And what is B here? B is, we found it from here to be 37.11. So this is the FE exam writer way to confuse you. They put the two parts exactly the same thing to confuse you, but you have to be careful with your calculation. If you are careful with your calculation, you have nothing to worry about. So this will give us the h to be 22.43, which is almost 22. So the answer is B. Now let's move into this question here. 3 circles, as shown here, of radii, this one and this one and this one, are tangent to one another. So as you can see, the graph here shows you what it means, or the figure. What is the interior angles of the triangle formed by joining the center? So we want the angles A, B, and C. So what we can use here is the law of cosines, and as we can see here, if you looked at the answers, you will find that the first angle, which is the smallest angle, is different from all of them. So if you just found the smallest angle, then you have solved the question. You do not need to use the other formulas. So if you just use this formula here to find the smallest angle, you do not need to find all the other angles. So let's do that. So basically what does that tell us is that we have here 110, which is the smallest one. So this one here is 110, and this one here is 110, and then we have the 140, the next largest. So 140 is here, 140 is here, and then we have 220 here and 220 here. So this will give us A, which is this entire here, this entire length here. So A will equal 250, and then we will have B to be equal 330, and then we will have C to be equal 360. Okay, just add these numbers, nothing here. So now we need to use the law of cosine, which is A squared equal B squared plus C squared minus 2BC cosine A. So not necessarily you need to have the same numbering here, the same naming, but whatever angle you will use here, whatever side you will use here, you will use it also here. Whatever side you will use here and here, you will use here as well. So what is A? We have A as 250 squared equals 330 squared plus 360 squared minus 2, 330, 360 cosine A. And now we just plug it into the calculator and let's find the A. And the A, we will find it to be as 42.2 degrees. So the answer is C. Now you could do the calculations to find these two, but that would be a waste of time because you have already found the correct smallest angle.